Sir Isaac Newton was the first scientist who studied the interaction of white light with the prism. So this is the glass prism. So let me write here as a glass prism. So here when we pass the white light onto the glass, at that time the seven colors get separated and we get a spectrum of seven colors. So you can see here red, orange, yellow, green, blue, indigo and violet. So this is the very interesting phenomenon occur when the white light interacts with the glass prism. Initially, thought was this glass prism actually separate or gives the seven colors, but actually this is not the case. Actually, the white light, or we can say it as electromagnetic light. So this white light is nothing but the electromagnetic light. So this electromagnetic light consists of different colors, that is the spectrum of light, and this was proved by the Sir Isaac Newton, again by placing the one more prism next to this prism, that is spectrum, again gives the white light. The separation of these seven colors is generally known as the dispersion of light. So here one can define the dispersion of light. So when white light passes through a medium like glass, at that time we get seven colors, and this spectrum or the obtaining of seven colors is known as the dispersion of light. So let me write here as a dispersion of light. Here we can define the dispersion of light, the process of separation of light into its component colors while passing through a medium is called the dispersion of light. Here the medium used is the glass. We get the exact seven colors by dispersion of light. Among these seven colors, the red bends least. So you can see here, but when we see the violet color, violet bends most. Among these seven colors, a red has the maximum wavelength. So I will write here as a 700 nanometer wavelength. So I will write here as a wavelength. If we have the wave at that time, in waves we have successive crest as well as the trough. So wavelength is nothing but the distance between the two successive crests. So this particular distance is nothing but the wavelength of that light, and its value is 700 nanometer. When we talk about the violet, at that time the wavelength of violet light is 400 nanometers, and also we can show it by using diagram. This is the successive crest, and the distance between these two successive crests is nothing but the lambda, that is wavelength. So we have 400 nanometer wavelength for violet as well as 700 nanometer wavelength for red light.